In this video, we're going to be talking about solving absolute value equations, specifically ones with one variable on one side of the equality. In these problems, we're always going to be looking for two solutions, but sometimes we will have one or no solutions. If you take a look at the absolute value equations, absolute value of x equals 5, absolute value of x equals 0, and absolute value of x equals -8, we're going to be solving each one of these and showing you what absolute value actually means. So what does absolute value actually mean? Absolute value is defined as the distance x is away from 0. So if I take a look at the absolute value of x equals 5, there are actually two numbers, -5 and 5, that are 5 units away from 0. So there are two solutions. We would say x equals 5 and -5. If we take a look at the absolute value of x equals 0, there is really only one solution that's 0 away from 0. So we would say our solution is x equals 0. And if we take a look at the equation absolute value of x equals -8, there's really no value that is -8 distance away from 0 because you can't have a negative distance. So a negative distance or a negative on this side of the equality means no solution. So we have three examples of two solutions, one solution, and no solutions. All right, so what's the process in solving these? There are 4 steps that I'd like you to follow in solving these. The first step is called isolating the bars. That's the first and foremost thing we do. We won't use the absolute value of equal to one number. So we want the absolute value equal to a number. So that's what we're going to get here. In this step, we have to do two things. We have to subtract 3 and then divide by 2 in order to isolate the bars. So if we subtract 3 from both sides of the equality, we end up with 2x minus 1 equals 6. Then how do we get rid of the 2? Well, we're going to divide both sides by 2, and x minus 1, still in absolute value, equals 3. So we've succeeded in isolating the bars, and the equation we're left with is the absolute value of x minus 1 equals 3. Second step. Our second step is to split into two equations. We want the absolute value of whatever's inside the absolute value equal to the positive value of this number, and the absolute value of whatever's in the absolute value equal to the negative of this number. And that's going to give us both cases where we're on both sides of the equality. both sides to 0. So the two equations that we want to split this up into are positive and negative. So we would say x minus 1 equals positive 3, and x minus 1 equals negative 3. All right, next step, solve the two equations. All right, these are pretty simple equations. I just add 1 to both sides in this one. So x equals 4. And this one, I would add 1 again to both sides. So it doesn't really change. But the answer actually changes because 3 plus 1 is 4 here, but negative 3 plus 1 is negative 2 here. So I now have my two solutions. And my last step is to graph solution. Okay, so on a number line, the two values that fit this solution are 4 and negative 2. So that would have been my graph. All right, so that was pretty simple. The only thing that's deviating from Algebra 1 is the first two steps, really. The rest of it is Algebra 1. So let's take a look at a few examples here. Step 1 says to isolate the bars. In this case, step 1 already done. And you're going to have some problems like that. Step 2 is to split. So I'm going to have the positive. So I have 15 minus 3x equals 6. I'm going to have a positive and a negative equation I need to solve. So 15 minus 3x equals 6, and 15 minus 3x equals negative 6. Come over here, subtract 15 from both sides, and negative 3x comes down equal to negative 9. Divide both sides by negative 3. X equals 3. In this case, we would subtract 15 from both sides again, but we're going to get a different answer. So negative 3x comes down equal to negative 21 in this case, and x equals 7 when you divide both sides by negative 3. So our two answers are 3 and 7. Graphing this, both answers are on the right hand side of 0, 3, 3, and 6, 7. All right, next one. We're going to isolate the bars. So step 1 is not done for us. We need to subtract 4 from both sides. Get rid of this because this is getting a little complicated here. Subtract 4 from both sides. And negative 2 on the outside of x plus 9 comes down equal to negative 9. Then we divide both sides by negative 2. So x plus 9, still an absolute value, equals 4.5, or 9 over 2, however you want to write it. I'm just going to write 4.5. All right, step 2 is to split into a positive and a negative case. So x plus 9 equals 4.5 and x plus 9 equals negative 4.5. In this case, we're going to subtract 9 from both sides, and x equals, we say, negative 4.5. Here we're going to subtract 9 from both sides, but negative 4.5 minus 9 is negative 13.5. So here again we have two solutions, and I could graph those the same as I did on the other one, or I could write it another way. You're going to say it is negative 13.5 comma negative 4.5, end your brackets. Okay, last one. I have to isolate the bars. That is already done for us. So I'm going to split into a positive and negative case. 2x plus 7 equals negative 2, and 2x plus 7 equals 2. So in this case, the positive version is actually the normal, negative 2, and the negative version is negative negative 2, which is positive 2. All right, so it looks like I need to subtract 7. 2x comes down equal to negative 11. Here I need to subtract 7. So 2x comes down equal to negative 5. Divide by 2 and x equals negative 5.5. Divide by 2 and x equals negative 2.5. So it would seem that I have two solutions here, but in reality, I have no solutions. Because let's think about it for a second. Whatever value I put in for x, it's never going to equal negative 2 if I take the absolute value of it. So let's say I put in negative 2.5 for negative 5.5 for x. This is negative 11 plus 7. Negative 11 plus 7 is negative 4. If I try and take the absolute value of negative 4, I get positive 4. There's no way whatever value I have for x is going to ever equal a negative 2 if I take the absolute value of it. So in this example, I didn't really need to do any of this. I just need to keep in mind that whenever an absolute value is equal to a negative, there is no solution. Now, the problem with this is if you don't memorize this, you can actually come up with solutions and think you're right. But you need to memorize that whenever the absolute value is equal to a negative, okay, after you isolate the bars, it's going to be no solution. Now you might be saying, well, wait a minute, this was negative here. Well, when I isolated the bars, after I was done isolating the bars, I actually had a positive on this side. So this is okay to go forward. So it's only after you isolate the bars, after doing step 1, where you've got to check whether this number is positive or negative. If it's negative, there's no solution. If it's positive, there is going to be two solutions. And that concludes our examples of one-sided absolute value equations.